Everyone. Today we are going to discuss the resultant of two vectors. So first of all, we will take the simplest case. So the simplest case would be you have a vector in the horizontal direction P, and there is another vector in the vertical direction, which is Q. The angle between two vectors is 90. So now we need to find the resultant vector. So we know we can parallelly transform the vectors. So I can transform this Q vector over here and P vector over here. So now it seems if you think your origin is O and this point is A and this point is B, so you can see now the resultant vector of P and Q would be R over here. So one can think that you are starting from A and then you are going to A position along the horizontal axis, and then you are going up in the vertical direction, and your corresponding vector would be Q. So now how to find R? So when finding R, there are two things, which is the magnitude of R vector and also the direction of the vector. So direction of R. So magnitude we can find using the Pythagoras theorem over here, and the direction we can find by using this alpha angle. So now what we can do, we will use the Pythagoras theorem. So P theorem. So if you use the P theorem, you use this to OAB right angle triangle. Use this for right angle triangle. So you can say R squared is equal to P squared plus Q squared. So from here you can find R, which is P squared plus Q squared square root. Now how to find this alpha? So to find this alpha, so we will use tan alpha to OAB right angle triangle, and that would be Q divided by P. So if you need to find alpha, that would be tan inverse Q divided by P. So this is our magnitude, and alpha would be our direction. So that's how you find the resultant of two perpendicular vectors. So now we will discuss if those two vectors are not perpendicular, how do we generalize it? Now P vector is horizontal, but Q vector here is not horizontal, which is going in an arbitrary direction. So the angle between those two would be theta. In our earlier case, the angle would be 90. So in this case, it would be theta. So now how do we get the resultant? So first of all, we will complete the parallelogram, and then as I told you, this one would be Q. Why? Because vectors can parallelly transform, and this one also P. So we will take the origin as O here, and this point is A, and that point is B. So if you want, you can take this point as C. So now the resultant vector would be the diagonal one, which is R vector. So now how do we find this R vector? So that is a challenging part, and also we have to find the angle between R and the horizontal axis alpha, which is the direction of the R vector. So now to do this, what we will do, we will create a triangle over here, which gives you 90 degree. So you can see this Q is the hypotenuse, and then let's take this point as D. So then BD you can write in terms of theta. So this angle would be theta. You can see that the corresponding angles. So BD would be Q sine theta, and then your AD would be Q cos theta. So now what I will do, I will use P theorem, Pythagoras theorem, to ODB right angle triangle. So if you use that, what you get, OB squared is equal to OD squared plus DB squared. So OD is nothing but OA plus AD the whole thing squared plus dB squared. Now, what is OB? OB squared would be R squared. So that is the value of the resultant vector is equal to OA would be P. AD, you can see it's Q cos theta and the whole thing squared plus dB would be Q sin theta. So that would be Q sin theta, the whole thing squared. Now we will try to simplify now. So this is going to be P squared, and then you get plus 2PQ cos theta, and then you get plus Q squared cos squared theta. Then from the second term you get Q squared sin squared theta. Now we can see, comparing these two terms, Q squared is a common factor, so you take that out, P squared plus 2PQ cos theta plus you take Q squared out, and then you get a relation cos squared theta plus sin squared theta. Now we know in trigonometry cos squared theta plus sin squared theta is equal to 1. So note, so this is what I'm using here. Sin squared theta in trigonometry, we know this, cos squared theta is equal to 1. That is the identity. So you can find R squared, which is P squared plus now Q squared plus 2PQ cos theta. So from here you can say R is equal to square root of P squared plus Q squared plus 2PQ cos theta, and that is your answer for the magnitude. Now how to find alpha? So if you look at the diagram here, we can still use ODB right angle triangle and find alpha. So using ODB right angle triangle, so I'm going to draw this one over here. So that is ODB over here. So this is going to be Q sin theta, right? So this is going to be alpha, and this length would be P plus Q cos theta. So that's what we had. Now this was R. So using tan alpha, one can write this is Q sin theta divided by P plus Q cos theta. So if you want alpha, that would be tan inverse Q sin theta divided by P plus Q cos theta. And that is your angle. So you can say the magnitude is R, so which gives by the first equation, and the angle is alpha from the horizontal axis. Okay, so if you have, now I can post this as a open question, right? So this is the open question. Please let me know if you need the answer to this one. So you can easily do this question using the knowledge I gave. So suppose your vector is P, it's horizontal in the positive x direction. Now your Q is other way around, so this way, and the angle would be theta. Now find the resultant vector, find the R vector. So you can see the difference between this problem and the previous problem I did. In the previous problem, the Q is in this direction, going away, outward from the origin. So this is inverse to the origin. So this is O, right? So in this case, so you have to find the R vector. So I will help you a little bit. So the first step would be you have to draw this one in this way because this is going other way around. So this is O, so this is Q. So and then you have to draw the parallel pipe, and then this would be your R. Okay, and this is the new alpha you are looking at. So I'm not going to do this question, but if you do this question, you should get R is equal to P squared plus Q squared minus 2PQ cos theta. So this angle would be theta. So this is what you should get if you do this question right. And the alpha value for this one would be tan inverse q sin theta divided by p minus q cos theta. So try this question as a homework question, and that's all about it. Thank you.